Okay, this is the video for section 7.5. In this video, we're going to talk about actually using the factoring. This is the main reason we learned all those sections on factoring is so that we can do this stuff in this section. So just like the rest of the semester has been, solving equations is kind of a key thing in all of algebra. And now we want to be able to solve quadratic equations. So a quadratic equation is anything that is in the form with an x squared term. So you see this has an x squared. Now, it's totally possible for these other b and c to be 0. But if a is not 0, then it has an x squared term, and that means it's a quadratic. And we especially can't solve directly like we can if it's just an x, if it's a quadratic, because, we might have these two different x terms, an x squared and an x, but we can't add them together because they're not like terms. And so we would never be able to get x by itself. So we have to do it by factoring instead of by directly solving. Okay, so we're going to use this property of the zero factor property. And we talked a little bit about this in previous sections when we talked about all the properties. In fact, I think on the test, I put you had to tell me about the zero property, and that is that if two things are multiplied together, and they equal 0, one of them had to be 0. That's the only way. Now, we all know that 0 times anything is 0, but it goes even farther. It goes the other way. If you multiply two things together and get 0, the only way you did that is if one of those were 0. And so that is a really powerful idea. And that's why we have to have things factored, because it's multiplied together, right? So if I add two things together and they get 0, they can be an infinite number of things. If I'm adding two numbers together and they equal 0, well, it could be 2 and -2, or 10 and -10, or 0.1 and -0.1, or 8.762 and -8.762, right? So there are an infinite number of solutions that I could write if I have two numbers added together. But if they're multiplied together, then I know that one of them has to be 0. And that is why we want things factored, because if they're factored, that means that is two things multiplied together. So here is an example we could use. So you see that this is already factored, right? I've got this factor, x minus 5, times this factor, 2x minus 7, and they are multiplied together and they equal 0. Well, that automatically means that either x minus 5 equals 0, or 2x minus 7 equals 0. One of those two things has to be true. And if x minus 5 equals 0, well, I can take this equation now and see what x would be, right? So add 5 to the other side, and I get that x equals 5. And if I add 7, I get 2x equals 7, and I divide by 2. So I get that x equals 7/2. So those are my two answers. I get 2, and both of them work. So if I plug them back in, when I plug the 5 in, I get 0 times 10 minus 7 times 3, but that's still 0, right? So that one worked. If I plug the 7/2 in, Well, let's do the second one first. I got 2 over 2. That cancels. Then I got 7 minus 7. So that one is 0 times whatever number that is. We could get a common denominator, make 5 10 over 2, and that'd be negative 3 halves. But it doesn't really matter because it's being multiplied by 0. So the answer is going to be 0. Right? And so typically when I have a quadratic with the degree of 2, so remember when we found the degrees of polynomials? Well, if a polynomial has degree 2, I can expect 2 answers. Sometimes it won't be true. I'll show you one in a second, where we only get 1 answer, but it's kind of like we get it twice. So that counts as 2, right? If it was a 3rd degree polynomial, then I'd probably expect to find 3. Okay, so in these, we're going to have these polynomials. We want to solve them by factoring. Now, you might be thinking to yourself, when you look at this equation, oh, well, I could just divide by x. You can't divide by x. Okay, so x is a variable, and x can be any number, even 0. And you know we cannot divide by 0. That's the one thing we cannot divide by. And we cannot even divide by something that might possibly be 0. Okay, so don't divide x. Don't divide by a variable. Don't divide by x. What we need to do is get everything on one side, because we're going to do this by factoring, and it's never helpful to factor unless it's equal to 0. That 0 property is why we can use factoring. So we will never factor unless it's equal to 0, right? At least for solving equations. So I will subtract the 6x to the other side. And then I have it equal to 0, and then I can start factoring. So the first thing we always do when we factor is pull out the greatest common factor, right? So we look here, and the greatest common factor will be 3x. And what's left in the first one is an x, and what's left in the second one is a 2. Now, this greatest common factor is one of our factors, right? Because it has a variable in it. So sometimes when we factor out a greatest common factor, it's just a number. And if it's just a number, then it can't equal 0, because it's going to equal whatever number it is. So we wouldn't count it. We wouldn't try to get a factor out of it. But if it has a variable in it, then we would. So we're just going to look at either 3x equals 0, in which case x is 0, right? Or x minus 2 equals 0, in which case x is 2. So those are my 2 answers. If I plug them into the original, you see that I get 3 times 0, which is 0, and 6 times 0, so 0 equals 0, so that one works. And if I plug in the 2, I have 2 squared, so you have to do the power before you do the multiply, so we get 4 times 3 is 12. And I plug the 2 in on the other side of the equation, and I get 6 times 2, so that's 12, so they both work. Okay, so here's one that's more, this is a quadratic, right? It's a trinomial, and it's not factored. And it is already equal to 0, but it's not factored, right? So this is just like the problems that we did in 7.2 when we were factoring. So pause the video for a second and see if you can factor that left-hand side of the equation. See if you remember how to do that. All right, so This one starts with an x squared, so when I find my two numbers, I can put them directly into my factors, right? I'm looking for two numbers that multiply to be 16 and add up to be negative 8. And oh, maybe I should have noticed that this was actually a perfect square, because it is. If I take the square root of 16, that's 4. If I double it, I get 8. And it would just have to be negative to get me negative 8, right? So it's going to be negative 4 and negative 4. Or you can look at it as a square. So it's x minus 4 and x minus 4. And it's equal to 0, right? So we don't want to forget that we have an equation here. So if you notice, I do have two factors, and I get an answer from each one. It just turns out they're both the same. And so this is what I was talking about. It's kind of like we got two answers, but there's only really one unique one, right? There's only one answer, but it happens twice, right? So x equals 4 would make that 0. So this time there's only one answer. And if we took that 4 and we plug it in, now it's easy to see in this equation, this factored equation, how it would equal 0. But if you plug it into the original before we factored, it equals 0 there too, right? Because really they are the same. All right, so 4 squared is 16. I can multiply these. So now if I add these together, my positive terms are 16 and 16, which is 32. And then I have a negative 32. So that equals 0. So you can see that that works even in the original before it got factored, right? They are the same. They're equal. So anything I plug into the original should give me the same answer as if I plug it into the factored. Okay, so here's another one for us to solve. You see that it's a quadratic, and we recognize it as a quadratic because it has a squared and it has a regular x, right? So it has an x squared and it has an x to the first power. And so I know I can't combine them. I have to do this by factoring. But it's not, there's something important that it's not, right? And hopefully you see that it's not equal to 0. It will not help us factor if we factor with it not equal to 0. It's not going to help us solve the problem. I could make an equation that's the same equation, it's equivalent, but it's not going to help us solve unless it's equal to 0. So we get it equal to 0. So we just need to subtract that 24 onto the other side. Okay, so now what's the first thing we always do when we're going to factor is we pull out a common factor. So I'm going to pull out 4. Out of everything, right? So now I have this quadratic. So now I'm just going to solve this part. I'm looking for two numbers that multiply to be negative 6, but they add up to be negative 1. And so if it's negative 6, that means there's a positive and a negative, and they have to be only 1 apart, because when I add them together, I'm just getting negative 1. So that's going to be 3 and 2. And I want my answer to be negative, so the bigger one has to be the negative one, right? And remember, as we talked about factoring before, that you can always double check. And certainly on the test, you should double check your factoring. And just multiply it out quick and see if you get the same as what you started with. So I do have 3 factors here, but this 4 out here, it doesn't have a variable in it. It's just a 4. And for me to say, well, when is 4 going to equal 0? Well, it won't, right? So it's not possible for this one to equal 0. So we can just ignore that one. we're just going to look at x minus 3 could equal 0, or x plus 2 could equal 0. So if I add 3 to both sides, I get x equals 3, and if I subtract 2 from both sides, I get x equals negative 2. So those are my two answers. Okay, here we go. Were you looking ahead on your paper and you saw this one with all the fractions and you thought, oh no, I hate fractions? I would never try to factor this with fractions. We don't know any methods for factoring with fractions. All the methods we've used have been with whole numbers for the coefficients. So the very first thing I need to do is get rid of the fractions. Now, I do know that it's going to be a quadratic because it has an x squared and an x, but I do not want to try to factor with fractions. So you really have to clear the fractions out of here. So you look at all the denominators and get the common denominator. So it looks like it's going to be 15. So since there's an equal sign, I can just pick 15 and multiply both sides of the equation by 15. Whoops. So we have 15 here, and 15 here, and 15 here. So those 15s will cancel, and I will be left with 2x squared. This 3 cancels with the 15, and I'm left with a 5, so I have minus 5x. And then this 5 cancels with the 15, and I'm left with a negative 3. All right, so there's my quadratic, but it's not equal to 0. So I need to get it equal to 0. So I'll add 3 to either side. Okay, so remember when we factor this kind that has a number in front of the x squared, we're going to multiply the 2 and the 3. That gives us our number that we're looking for, that if we multiply two numbers together, I get 6, positive 6, so they have to both be the same sign, but they're going to add up to negative 5. So they have to be the same sign, so they're both going to be negative, because it has to add up to negative 5. So it could be 1 and 6, but that would add up to negative 7. So it looks like it's going to be negative 2 and negative 3, because that'll multiply to be 6, but it adds up to be negative 5. So I can't just plug them straight in to an equation. I need to do it by grouping. I have 2x squared. So I'm going to change negative 5 into negative 2x and negative 3x. And the last one is 3. Now pull out all the common factors on the top. So that's a 2 and an x. And that leaves me an x up there for the first term. And 2x times something has to be negative 2x, so that's going to be a negative 1. And x times something has to be negative 3x, so that's going to be negative 3. And then I'll just double check for the last one. Negative 3 times negative 1 is positive 3. So it all worked. So my two answers are x minus 1. My two factors are, and 2x minus 3. And it's still equal to 0. And you notice that every time, like you may go off and do some work, but you really need to be writing down that whole equation every time so you don't lose parts of it. Okay, so here I have it factored, and it's equal to 0. So I can just go ahead and take each thing. Z equal to 0. And so x is equal to 1. If I had 1 on both sides, right? And I have 2x is equal to 3, and I'll divide by 2. So my two answers are 1 and 3/2. Okay. So in this case, it looks like it's already factored, right? X plus 5 times x plus 5. But the problem is that it's not a factored thing equal to 0. And so, since it's not equal to 0, it's no good to us. So we need to unfactor it and put the 36 over there and then refactor it. All right, so we will multiply out x plus 5. So we have x squared plus 10x plus 25. So I was using that rule we had about squaring a binomial, and certainly if that's not comfortable for you, then go ahead and multiply it out and distribute it or put it in the box or whatever. Equals 36. I'm going to subtract the 36 from the other side so that it's equal to 0, right? So now I have x squared plus 10x minus, okay, so we have, it's going to be 11, I believe. So now I'm looking for two numbers that multiply to be negative 11, but add up to be positive 10. So pretty much the only thing we got going for 11 is 1 and 11. They have to be opposite signs because it's negative 11. And so I want the bigger one to be positive because my answer, my 10, is positive, right? So it is going to be x minus 1 and x plus 11. So that means we take each of those factors. X minus 1 equals 0. So x equals 1. And x plus 11 equals 0. So x equals negative 11. Those are my two answers. This looks like it's factored all over the place, but once again, it's not equal to 0. So I want you to pause the video, distribute all this out, multiply it out, and then get all the terms on one side, get them into a nice standard order that you can factor, and go ahead and factor it. And see if you can get the two answers for this problem. Okay, so hopefully you got it. When we distribute this, oops, we distribute this, we get 3x squared minus 3x equals 10 minus 2x. And then we want to get everything onto the other side, so I'm going to add 2x and subtract 10. So I will have 3x squared. So now I have negative 3x and positive 2x is negative x. And negative 10. And now that's going to equal 0. I hope I didn't skip too many steps there for you. So if I did, go back and do those steps all out and see if you can get to this same step here. So now we're going to multiply the 3 and the negative 10. So I got negative 30. I'm looking for two numbers that multiply to be negative 30 but add up to a negative 1. So there's one positive, one negative because it's negative 30. You have to be only one apart. So that's going to be negative 6 and positive 5. So we've got our 3x squared, negative 6x, 5x, and negative 10. So as I pull common numbers out of the top, I get 3x. This will be an x, and this will be negative 2. And x times 5 is going to give me 5x. And just to double check, 5 times negative 2 is negative 10. So those are my two factors, x minus 2 and 3x plus 5. So that means that either x minus 2 is 0 or 3x plus 5 is 0. And then I solve each one of those. X equals 2. I subtract the 5 over and divide by 3. So there's my answer, negative 5/3 and positive 2. Okay, so take a look at this. And what do you think is the difference between this and the ones we have been doing? There are lots of things the same and a few things different too. It's still a trinomial, right? We've done a lot of trinomials. The difference is it's a cubed, which pretty much means we're looking for 3 answers this time and not 2, right? Now we don't know how to factor very many cubes, but in this case, what's the first thing we would always do if we're trying to factor is we would factor out a common term, and so that's going to include an x, so that will make it so we can factor the rest. So 2x, it looks like it's going to be my greatest common factor. And that leaves me with an x squared. And a 2 out of here would be a 2 and an x. And a negative 3. All right, so go ahead and pause the video and see if you can factor that middle term, this quadratic. By yourself, turn the video back on and I'll show you how to do it. Okay, hopefully it went well. So this is just an x squared, so when I find my two numbers, I can just put them directly in here. Right? I want the two numbers to multiply to be negative 3, but add up to be negative 2. So there's not a lot of choices with 3. It's got to be 1 and 3. And since they're opposite signs and I want it to equal negative 2, the bigger one, 3, has to be negative. So this can be x plus 1 and x minus 3. So now you say I have three factors, and that's going to give me my 3 solutions that I was looking for. First of all, 2x equals 0. In other words, x is 0. Or x plus 1 equals 0. Or if I subtract 1, that's going to be negative 1. Or x minus 3 equals 0. If I add the 3, x equals 3. So those are my 3 answers. And I expected 3 answers because it was a cube. It was a third power, third degree polynomial. So just to kind of recap, remember that if you see that it's a quadratic, we will have to do it by factoring. So you have to get everything on one side and make sure it's equal to 0, right? And then you're going to factor completely. And you want to factor it all the way as much as you can. Make sure everything is factored. And that will, so that we have a bunch of factors equal to 0, right? And then we go through and we set each one of those factors equal to 0 and find out what the variable would need to be. And then you can check them one at a time. They should all work, right? So here's that one common error which people are tempted to make. We mentioned it before. You cannot divide by a variable because that variable might possibly be 0. You can't do it. So here's some practice problems. Pause the video. Do these 4 problems. They're just like the ones that we just did. And then turn it back on. I'll show you the answers. Here are the answers. Hope you found them all. I'll see you in class.